You came back to learn more, and that's great. Okay. In this video, we are going to talk about algorithm verification in diagnostic, or simply testing. We will simply test if our algorithm is correct. Okay, if it works really well. So simply, algorithm verification in diagnostic is using systematic visual tools and dry runs to spot structural program logic flaws before compiling a single line of real code. So before writing our code in our algorithm, we will check our algorithms if it is completely correct and if it is giving us correct output every time we just want. Okay. So see the logic of verification, we just use dry runs. Okay, so what is a dry run? A dry run is a manual pencil and paper execution of an algorithm. Okay, this is performed without a computer to understand program flow and proactively. It means just before writing your code, okay, catch logic errors before a single line of actual code is written. Okay, so that is dry run. Checking if your algorithm is correct before writing any line of code. Okay, and what are the benefits of this? Okay, the first one is visibility. It reveals the hidden state of the computer's memory at any exact millisecond. Whenever just value of any variable changes, you can just see there. Okay, then validation, it proves the written logic actually works for expected inputs. So you will just check different inputs. Okay, erroneous data, normal data, boundary data. Okay, and simply it will prove that yeah, this algorithm or this steps will work, and it will just give us correct answer every time. Okay, and after that, vulnerabilities. Okay, it identifies exactly where a program will crash or behave unexpectedly. Okay, so it will find your errors, it will find your problems. Okay, so that is what dry run is. And every dry run tracks execution progress across three architectural zones. Input, simply it checks the raw parameters fed to variables, okay, data or things like that. Processing, when the value of variables change, it just simply checks that and what happens there, what value is counted and stored inside any variable at which point of time. And output, okay, and what will be the final result that will be pushed to the user. Then for dry runs, we can use trace tables. Okay, trace table is simply a table in which you will just simply have columns for your inputs, columns for every variable that you have. Okay, and one column for output, and each row will state a new data change. Okay, there. So memory, each column tracks a specific variable, input or output. This is the computer memory. Okay. Then time, each row represents a single step in time, a line of execution, or a specific pass through a loop. And in trace tables, we can have empty cells. Okay, empty cells or blank cells mean the variable's value hasn't changed. Okay, the last value that is written inside the table, that is just the value inside it. Okay, so whenever the value changes, then there we will just simply write in that row that yeah, this time the value changed from that to this. Okay, if in any row the value of any variable does not change, we will just simply let it be blank. Then step by step dry run execution. The first one, initialize. Okay, set the starting values for variables. Okay, whether that is in input or whether that is just hard coded values. So for variables, you will just simply say that yeah, this is the initial value inside the variables that we have got, and then execute. Okay, read the algorithm line by line exactly as written, no skipping ahead. Okay, so you will execute and you will perform all the calculations that are just told inside the algorithm. Then update, record any changed variables in a brand new row of the trace table. Okay, so inside trace table, you will write here this variable's value changed to something like this. And after that, again check condition. Okay, you will just again check the condition to check if you just need to perform these things again or no, just the condition is false and you will just exit the loop. Okay, so that is what you will keep doing. Okay, then Some rules for exam. Okay, rule number 1, they stop condition check. Always evaluate the loop conditions before recording a new row. Okay, do not execute the loop body if the entry condition is already false. So every time if you have just gotten a loop, check the condition. If the condition is true, then just perform it. Again, check the condition. If that was true, then just do that. Okay, rule 2, keep the memory clean. Record only the values that explicitly change in a step. Do not rewrite a variable's value on every single row if it has not updated. Then rule 3, the final output. Okay, never forget the final output instructions that occurs after a loop finishes. This is frequently missed mark in the exam. Okay, so you have to have one row for your output, and just you have to clarify that this will be just the output. Let's just work on some examples, okay, for the trust table and dry run. See, we have gotten this code here, or just maybe a pseudo code here. Okay, so that will be num1 is a variable. See, num1, num2. Okay, and then output. In this program we do not have any input, so we do not have any column for any input. Okay, then total is equal to num1 plus num2. Then while num1 is smaller than total, that is our condition. Okay, then num1 is equal to num1 plus 1, and num2 is equal to num2 plus num1. And when this finishes, print num2. So let's just trace it line by line. Okay, so as you can see, num1 is equal to 2, num2 is equal to 3, and total is equal to num1 plus num2, which is 5. Then while this condition is num1 is smaller than total, yes it is. So see, we will just enter the loop. Num1 is equal to num1 plus 1, so 2 plus 1 will be 3, and num2 will be num2 plus 1 plus num1, so 3 plus 3 will be 6. Then we will just check the condition again. If the condition is true, so is num1 smaller than total? Yes, so that is just true. So again we will enter, so this will be 4. Okay, num1 plus 1, that will be 4. Then num2 is equal to num2 plus num1, so that is 4 plus 6, that will be 10. And again we'll just check the condition. Is num1 smaller than total? Yes it is. So again num1 is equal to num1 plus 2. Okay, so that is 4, it will be 5. Then 4 plus 10 will be 15. Okay, stored inside num2. And now we will just check our condition. Is num1 smaller than total? No, it's not smaller. Now they are equal, so this condition becomes false. Okay, so when it is false, we will just get out of the loop. So getting out of the loop, we will have print num1, which is our output. Okay, num2. So inside num2 we have gotten 15, so our output will be 15. So that is an example for trace table. And see here, because total did not change, we did not write anything in these cells. Okay, we just simply left them blank. Another example, okay, for that again. So result is equal to 1, total is equal to 0 for the power in range 0 up to 4, or for the power in 0 from 0 up to 4. Okay, so total is equal to 2 to the power of the power. Okay, whatever just power is there. Total is equal to total plus result, and print result, print total. Okay, so we've just gotten that. So result is equal to 0, total is equal to 0, and 4 power in range 0 up to 4. So it will start from 0 and go up to 4. So the power for now, that is 0. Okay, and we will just perform this. Result is equal to 2 to the power of the power. So 2 to the power of 0 will be 1, and total is equal to total plus result. 1 plus 0 will be 1. Then because this is 4, automatically the value of the power will change to 1. Now again result is equal to 2 to the power of the power. So our power is 2 here, so 2 to the power of 1 will be 2. Then total plus result, 2 plus 1 will be 3. Okay, stored inside total. Then finished, automatically it will just go to 2 up to 4, we will just go there. Okay, so 2, that is just acceptable, and we will just result is equal to 2 to the power of the power. Okay, so 2 to the power of 2 will be 4, and total is equal to total plus result. 4 plus 3 will be 7. Okay, and again we will just go one step further in our loop. The power will become 3. Okay, and now result 2 to the power of the power, so that will be just 2 to the power of 3 will be 8, and 8 plus 7 will be 15. Okay, and after that, yeah, we'll just check 4. It will not go to 4. Okay, because range that will stop here. Okay, so 1 0 1 2 3 4, and when we just simply got out of this, then yeah, our result will be print result is 8, and print total is 15. Okay, so that is another example for the trace table. Okay, and the range function, yeah, 0 up to 4 executes 4 times from 0 up to 3. Okay, 4 itself is not hit there. So see, while we are just checking our code, we are just looking for errors. Okay, and we have to know what types of errors are there so we can just recognize them. Okay, so we have gotten 3 types of error in programming: syntax error, logic error, runtime error. What are each one of them? Okay, syntax error is rules of the programming language are broken. Programming language says, yeah, here you have to use a colon and you have not used that. Okay, so that is just a syntax error. Then what happens? Okay, program fails to compile or restart. Okay, if you just, when you hit run, your program will tell you that, yeah, in this line you have gotten a problem. Okay, so examples: misspelled keywords or missing brackets. So see here, int max value is equal to 5. Okay, now that is just in languages like Java. Okay, so in Java we have to have a semicolon here. We do not have that, so this is a syntax error. Okay, when I just add a semicolon there after 5, it will be just completely fine. Then the second one is logic error. Okay, code runs but instructions are fundamentally flawed. Okay, so yeah, let's do this again. Then the second one is logic errors. Code runs but instructions are fundamentally flawed. It means your calculations are wrong. Okay, and things like that. What will be the result? Your program will not crash here. Simply we will have incorrect output. Examples, for example, using larger instead of smaller, or dividing instead of multiplying. Now they are accepted operations, okay, acceptable operations in programming. So your program will just keep doing that. It does not understand that, yeah, this is wrong, because as we told you, computers are mindless machines which are only good in following instructions. Okay. Then after that, we have gotten runtime errors. Runtime errors, simply an impossible operation is requested mid execution. So what happens? Program starts, but then when impossible operation is requested, it will suddenly crash. Okay. Examples for that is dividing by 0. See, that is impossible operation. Or index out of range. You have the highest index in an array that you have is 5, but you are just looking for index 6. Okay, so we have gotten 3 types of errors: syntax errors, logic errors, and runtime errors. And you will just try to find these errors. Test design. Okay, as we just discussed about normal data, boundary data, and erroneous data, this is just an example for that. Okay, think about this. If we are looking for, or if we are just writing a program that accepts, or the acceptable number there is between 1 and 50, so normal data can be just kind of 10, 25, 26, 30. They are just normal data. Okay, typical valid data that should easily pass. Then boundary data, absolute extreme edges, crucial for catching logic errors that are caused by using greater instead of greater and equal, or smaller instead of smaller and equal. Okay, so here our boundary data is 1 and 50. Then erroneous data, that is data that must be rejected. Tests the algorithm's defense mechanism. Have you just done the validation correctly or not? Okay, so for example, -5 or 0, or just kind of 55 or things like that. Okay, so there are erroneous data. Some tips for your exam. Okay, the first one, initialization trap. be careful about this. Many students lose marks from this, okay, because in programming sometimes you do not need that in some languages, but in pseudocodes you have to just write that, okay. So mark point 1, it means 1 point in paper 2. Coding question is frequently awarded simply for correctly declaring and initializing variables. Example, setting counter to 0 or thing like that, okay. Never skip that, even if you do not need that in your programming language, okay. So do that. Precision in terminology, okay. Do not just write the code is broken. You must specifically identify the failure as a syntax error, logic error, or runtime error. Exact terminology secures the marks. See, in mark schemas it is written, if a student has mentioned logic error, give him 2 marks. So if you do not mention logic error and you just simply say their error, you will just lose those 2 marks, okay. Then output formatting, be careful about this. For example, your output has to be clean. For example, if a space is needed somewhere, you have to just do that, okay. For example, see here, score 10, that is just acceptable, there is a space. But if you just write something like this, you will lose some marks. So in the output, be careful, okay. Study how to add spaces, or even if you just use extras. For example, in Python, if you concatenate 2 values with comma and you have just added 1 space here as well, so comma itself will also add a space, okay. So it will be 2 spaces, so again you might lose marks. So your output has to be just cleanly formatted. Again, okay, some questions here. Think about them and try to just find the answers for them, okay. Define the term dry run and state 2 distinct reasons a programmer would perform one before writing their code. Think about that. We just discussed about this in this video. The second one, an algorithm accepts user ages between 13 and 19 inclusive. It means 13 and 19 are also accepted. State 2 pieces of boundary data. So that will be 13 and 19 itself, and 1 piece of erroneous data you would use to test it. So for example, it can be 20, 21, or 12, 11, or things like that. Then problem solving. Here you are just given a code. Identify the exact type of error in this snippet and explain why it will ultimately result in a program crash. Okay, so we have gotten that x is equal to 10 and x is just kind of added 1 every time, and our condition is if x is larger than 0. So x is larger than 0 at first and x is incrementing, so every time it's just adding by 1. So that is just kind of it will just simply create a logic error. Wish you all the best, good luck, and goodbye. Keep learning, keep shining, and follow our channel.